There's been a real buzz lately around something called Model Context Protocol, or MCP.
Yeah, definitely hearing that name a lot.
It feels like everyone's talking about it, but maybe it also feels a little like trying to understand a whole new language sometimes.
That's a good way to put it. It can seem complex.
So that's exactly what we want to dig into today. We're going to unpack MCP, look at how it works, and really try to understand why it's such a big step for AI agents.
But without getting totally lost in the weeds, technically speaking.
Exactly. Keep it practical.
Absolutely. And we've got some great stuff to draw on. There's a really detailed technical blog post from WWT that gives us the foundations.
Okay.
And we're also looking at explanations from Professor Ross Mike on YouTube. He's really good at breaking down these kinds of complex ideas.
Makes them accessible, yeah. So our goal today is pretty simple, really. Take the technical core of MCP, translate it.
Make it make sense.
Yeah, clear, practical narratives. Define the key terms, figure out how it actually works in practice, and why this matters if you're watching how AI agents are evolving.
Look, that was good.
Okay, so maybe first things first. Where did this whole idea of these more capable agentic AI systems even come from? What came before MCP?
Right. Well, it's kind of a natural evolution. We
Hmm.
started with these large language models, LLMs. Super powerful for text, understanding language, generating it.
Yeah, amazing stuff.
But pretty quickly, people realized, okay, on their own, they can't really interact much with the outside world. They're kind of stuck in the text box.
Ah, okay.
So that's where this idea of agentic systems started. The first big step was giving LLMs the ability to use external tools.
Mm-hmm.
That happened through something called function calling.
Function calling, you mean the LLM could basically say, hey, I need this done, and trigger some other software.
Exactly that.
Yeah.
And even before that, a key step was retrieval augmented generation, RAG. You probably heard of that.
RAG, yeah.
Yeah.
That's about giving it extra documents, right?
Precisely. Boosting its knowledge, giving it specific, relevant info along with the user's query, so it wasn't just limited to its training data.
Yeah.
Then, this idea of context got broader. It wasn't just documents. It started including real-time data pulled from APIs.
Like livestock prices or something.
Yeah, or accessing specific features of another online service. And that evolution led to what we generally call tool calls.
Right, so moving from just static info to actively using tools to get dynamic data. But I remember hearing somewhere that LLMs, by themselves, are pretty passive.
That's a really crucial point. Professor Ross Mike makes this point well. LLMs alone are fundamentally just predicting the next word. That's their core function.
Okay.
They're great at generating text, answering questions based on training, sure. But ask one to actually do something in the real world, send an email.
You can't?
Nope. It just lacks the built-in capability. It can't directly poke external systems.
Okay, that makes sense. So it's connecting them to these tools that unlocks their potential, lets them do more than just generate text, like searching the web, maybe.
Exactly. Hook up an LLM to a search API, and suddenly it can find current information, tasks that were impossible before.
But there was a catch, right?
Oh, yeah. Greg Eisenberg talked about this, created this new headache, the gluing problem.
Glue.
Yeah, imagine you want an AI assistant. It needs to search the web, check your calendar, then send a meeting invite.
Okay, multi-step.
Right. And you had to somehow connect all these different tools, search, calendar, email, to the LLM, and making them work together smoothly for complex tasks. It was frustrating, really difficult and brittle.
I'm picturing lots of digital duct tape. Sounds like things could break easily.
That's a perfect image. Very fragile setups.
So this is where MCP finally comes in to fix the gluing problem.
This is exactly the problem MCP aims to solve. It's a standardized framework. Anthropic released it November 2024.
Okay, recent.
Yeah. And MCP is basically a defined set of rules, a protocol for how you give data and tools to an LLM. The goal is building these agentic systems, but in a consistent, predictable way.
Ah, so the core idea is self-contained, reusable tools.
Exactly. Connected to the agent in a standardized format. No more custom glue for every single connection.
Standardized, that feels like the really important word there, doesn't it? Instead of every tool speaking its own dialect.
Totally. Professor Ross Mike uses this great analogy. Think of MCP like a translation layer.
Okay.
It takes all the different languages these tools speak and translates them into one unified language the LLM understands easily.
Makes sense.
So it builds on the agentic idea, but provides this specific protocol for how services provide data. And crucially, instead of direct tool calls, the agent now interacts with things called servers.
Servers. Okay, hang on. So the LLM isn't talking directly to the, say, calendar tool anymore? It talks to a server that manages the calendar tool.
You got it. In MCP land, a server represents a single service or piece of software. Could be a database, GitHub, a browser you control with code, an API, anything you want the agent to use.
And the key is modularity, you said.
Right. Each server connects to just one main service. That's a big shift. Before, you might have had code trying to juggle connections to 5 different things all tangled together.
Okay, so it's like breaking down a big complex machine into smaller standard parts you can swap in and out.
Perfect analogy. And what's cool is there's this growing ecosystem. Anthropic makes some servers first-party ones,
Right.
but there are also third-party ones. Companies are building them. The open source community is building them.
Like for what kind of services?
Oh, the WWT blog lists
Right.
examples like GitHub, Slack, Puppeteer, that's for web automation, Grafana for dashboards, Milvus for vector search. Even things like PayPal and Gmail servers are appearing.
Wow, okay. That's quite a range.
Yeah, and some even come as ready-to-go Docker images. Makes setup easier.
Hmm.
And handling credentials like API keys, that's usually done securely through environment variables. Less risky.
Okay, much cleaner. So what are these servers actually made of? What are the building blocks inside?
Good question. 3 main parts to an MCP server: tools, resources, and prompts.
Okay, tools first.
Tools are basically the functions the underlying service can perform. They need arguments, inputs from the user or the LLM to actually run.
Examples.
Like a Puppeteer server might have a Puppeteer Navigate tool that needs a URL. A GitHub server could have tools for managing issues, branches, PRs. Each needs info like the repo name, issue ID, that kind of thing.
Makes sense.
And importantly, you can also create custom tools that bundle up several actions within that one service.
So a single tool call could actually trigger, say, creating a branch and adding a file in GitHub.
Potentially, yeah. If you design the tool that way, it offers more complex actions.
Okay, what about resources? That was the second part.
Resources are the data sources the server makes available to the agent. Context, basically.
Like files, databases.
Exactly. File systems, database content, API responses, maybe even screenshots from a browser tool or live data feeds, anything that provides context for the LLM.
And how does the LLM ask for a specific resource?
They're identified using URIs, Uniform Resource Identifiers.
Oh.
Think of it like a very specific web address, but for data within a service.
Okay.
So a file in GitHub might have a URI like repo.owner name, repo name path to file.txt. It tells the system exactly where that piece of data lives.
Like a precise address. Got it.
And MCP also has this idea of resource templates. These are like reusable URI patterns with placeholders.
Placeholders.
Yeah, like repo.owner name, repo name path. The LLM can then fill in the blanks, the owner, the repo, dynamically based on the current task.
Okay. So it's not locked into one specific file. It can ask for different ones using the template. That sounds really flexible.
It is very powerful for dynamic data needs.
All right. And the third part was prompts. What are those in this context?
So prompts here are like user-defined templates, but for standardizing repetitive tasks.
Okay.
You can set up a prompt, define the arguments it needs. Then when you use the agent, you just pick that prompt template and fill in the argument values.
Example.
The WWT blog mentioned one for making GitHub commits. You'd set up the prompt for a specific repo, maybe, and then you'd only need to provide the commit message each time you use it.
I see. Like a shortcut for common workflows.
Exactly. And you can even chain these prompts together for multi-step processes. Though it's worth mentioning, WWT felt that maybe prompts, right now, offer less of a leap forward compared to the core value of standardized tools and resources.
Interesting perspective. So the main power is really in the tools and resources structure.
Seems to be the thinking, yeah.
Yeah.
At least currently.
Okay, so we've got these modular servers with tools, resources, maybe prompts. How does the main AI app, the LLM part, actually use them? How does it talk to them?
Right, that brings in the host and the client. The host is the main application you interact with.
Like Claude Desktop you mentioned. Or maybe an IDE.
Exactly. Claude Desktop, an IDE with MCP support, maybe even a command line tool. That's the host. And inside the host is the client.
The client.
The client is the bit of code that actually manages all the back and forth communication between the LLM and all the different MCP servers it might be connected to.
So the client is like the traffic controller, making sure the LLM can use the servers properly.
That's a great way to think about it. Yeah, the coordinator.
Yeah.
The WWT blog breaks down its main jobs.
Yeah.
Setting things up, managing the server connections, handling the LLM's requests, which often means calling server tools, dealing with the user interface, and managing the data resources being used.
Okay.
Now, if you're using something like Claude Desktop, a lot of that client code is hidden from you,
Yeah.
abstracted away.
So you don't have to write it yourself.
Right. The main thing you usually interact with directly is just setting up which servers you want to connect to.
And how does that client software actually talk to the servers? What's the connection method?
It's usually a one-to-one connection between the client and each server.
Okay.
And there are two main ways they communicate. If the server is running locally on the same machine,
Yeah.
they can just use Studio standard input-output, like a direct pipe between the two programs.
Yeah.
Simple.
And if the server's somewhere else, like on a different machine or in the cloud?
Then they use HTTP and server send events, SSE, with the messages formatted using JSON RPC. It's a more robust method for network communication.
JSON RPC. Got it. Standard way for systems to talk over a network. And how does the client even know what servers exist and how to start them?
That's usually defined in a server configuration file, typically JSON format.
Okay.
It sits in the host applications directory somewhere, and it lists the command to run each server, any arguments it needs, and those environment variables we mentioned like API keys.
All right, that covers the technical side pretty well, I think.
Yes.
Let's switch gears a bit. What are the real advantages here for developers? And what about bigger picture, like business implications?
Yeah, good question. For developers, WWT points to three main wins. First, just better organization. Grouping tool calls logically within their services makes code cleaner.
Okay, less spaghetti code.
Definitely. Second, standardization. Having services connect in a consistent way makes integration much easier.
Right.
And third, maybe the biggest one, reusability. You build a server once, say, for your company's internal product database, and any AI agent project can potentially reuse it.
Ah, so that directly tackles that gluing problem. Saves a ton of repeated effort, presumably.
Huge savings in time and resources is basically taking solid software engineering ideas,
It's
modularity, standards, and applying them to this AI agent context.
Makes perfect sense.
And it's not just for hardcore coders either. Things like Claude Desktop make it accessible. Even non-technical folks can start configuring basic MCP setups using those config files.
That lowers the barrier to entry quite a bit.
For sure. Plus, there are SDKs, software development kits for TypeScript, Python. Tools like FastMCP are emerging to help build custom bits more easily.
Okay. Now, what about that bigger business impact? The Confluent developer video hinted MCP was more than just a desktop thing.
Absolutely. Their take is that MCP is really foundational. It's what could enable proper, powerful agentic AI within enterprises, going way beyond just making desktop apps smarter.
How so?
They really emphasize pluggability, easily adding new capabilities via servers. Discoverability, making it easy for agents and developers to find out what tools and resources are available. And composability, mixing and matching servers to build really complex, sophisticated workflows.
Okay. Pluggable, discoverable, composable. Sounds powerful. They had an example, right? Appointment scheduling.
Yeah, it's a good one to illustrate the flow. Let's say you ask an agent, schedule a meeting with Bob next Tuesday.
Okay.
The agent, using MCP, first asks what capabilities are available. It discovers maybe a calendar server and a contact server.
Right.
The LLM reasons it needs to check your calendar via the calendar server's resources and get Bob's email from the contact server. The client makes those requests to the servers, gets the availability and the email address. Maybe there's some back and forth to confirm a time. Then the agent uses, say, an email server tool to actually send the meeting invitation.
And the key is that the calendar logic, the contact logic, the email logic,
Yeah.
they're all separate, reusable servers.
Exactly. That same calendar server could be used by a different agent booking travel, or another one managing factory schedules, or your personal AI helping plan your day.
That's the reusability payoff. Build once, use many times.
That's the promise. Modular tool calls via standardized servers. It's a potential game changer for efficiency.
It's still early days, right? Are there downsides or things to watch out for?
Definitely. The WWT blog is realistic about this.
Yeah.
MCP is still pretty new. Things like building really complex custom components or robust security practices around these servers, that's all still evolving.
So caution is needed.
Yeah, especially with third-party servers. Do your research, understand what they do, how they handle security. It's not quite plug and play for everything just yet.
Makes sense. Security is always huge. But that idea of companies building internal marketplaces of their own reusable servers, that sounds really interesting.
It really does. Imagine like, the tractor-trailer retailer example they used.
Yeah.
Sales, support, inventory teams. They could all use the same core servers for accessing product info or logistics APIs. Massive reduction in duplicated work. Creates compounding value over time.
Build it once, everyone benefits.
Exactly.
Okay.
And Professor Ross Mike even floated the idea of an MCP app store.
Like for discovering and deploying these servers easily.
Yeah, imagine just browsing and clicking to add a GitHub server or a Salesforce server to your agent. That could really streamline things for developers down the line.
Okay, that paints a pretty compelling picture of where this could go. So if we were to wrap this up, bring our deep dive to a close, what's the core takeaway on MCP?
I think the core significance is that MCP represents a really important step towards making AI agents more powerful, yes, but also more manageable.
Manageable how?
Through standardization and modularity. Applying those solid software engineering principles, breaking things down, defining interfaces to how agents connect to tools and data, it gives us a more robust, scalable way to build these complex systems.
Right, not just fancier chatbots, but systems that can actually integrate and do more reliably.
Precisely.
And for you, listening in, hopefully this gives you a clearer picture of the tech driving this next wave of AI agents, what's happening under the hood, and why it could matter for future applications.
Yeah, it really opens up possibilities, which leads to maybe a final thought for you to chew on.
Go for it.
How could standardized protocols like MCP, even though they're still early, unlock new things in your field or in projects you're thinking about? Think about the services, the data sources you use all the time. Could they be broken down, modularized, made reusable through something like this? What efficiencies or new capabilities might that unlock?
That's a great question to consider. Where could this modular approach make a difference?
It's definitely something to watch as MCP and ideas like it continue to develop. The potential impact is pretty significant.
Absolutely. Well, thanks for joining us on this deep dive into Model Context Protocol. Definitely an exciting space.
For sure. Lots more to come, I think.
Until our next exploration, keep exploring.